Welcome to Decorators in Python. In this module, we'll learn about decorators, we'll study the anatomy of a simple decorator, and answer questions like why use a nested function. We'll talk of parameters and the Py syntax, then we'll learn to chain decorators and discuss their disadvantages. A decorator is nothing but a function that adds some functionality to another function, but does not modify it. This is like a gift wrapper. A gift wrapper wraps a present in something, but does not modify the contents. This is something called metaprogramming. This is where one part of a program tries to modify another at compile time. So this is useful when you want to add functionality to a function but don't want to modify it. Let's take a simple decorator. We have a function decor. This holds a function wrap. This makes a call to func, the argument to decor, and adds print statements before and after this call. Finally, the decor function returns wrap. We also have a function sayHello that prints out hello. Now we make a call to decor with sayHello as argument, since it takes a function as an argument, and call this newfunc. Finally, we make a call to newfunc. As you can see, this prints out two lines of dollars and the output of the function sayHello between them. Let's break this down. Function sayHello prints hello. Now the function decor. This is a higher order function since it takes another function. And since we'll be passing the sayHello function to this, we can also define it after sayHello. Decor takes a function as an argument. This is the function it will decorate. Okay, now the wrap function inside decor. This is where we declare what to do to the function we're decorating. This is also where we make a call to the function we want to decorate. This is the function. It prints out two lines full of the dollar sign and makes a call to the function it decorates. This is between the two lines. And then decor returns wrap. So this was the definition part. Now when we call decor with the sayHello function as argument, we can call it newfunc, and then we make a call to it. We can also just reassign this to sayHello instead of calling it newfunc. You're probably thinking, why did we need to nest a function here? Couldn't we just have decor do it? Let's see what happens if we don't use the wrap function or whatever you'd like to call it. Here, we perform the decoration in decor itself, then make a call to decor with sayHello as argument and call it newfunc. Assigning this call printed this to the screen. This means it doesn't return a value but prints something to the screen. And when we make a call to newfunc, we can't. Are decorators only good for print statements, or can they do more? Let's build a function that divides two values. The decorator function takes a function as argument. Divide and wrapper take two values in A and B. This also has an if condition that checks whether the denominator is 0. Decorator returns this wrapper. The return func statement in wrapper remembers the value of func. This is closure. We'll discuss this in the next lecture. Also, it is possible to pass args and quarks to the wrapper. Now let's call the decorator on the divide function and call it myfunc. Myfunc of 2 and 3 is 0.66. The myfunc of 2 and 0 means 2 by 0. This would raise a 0 division error, but since we decorated it to handle this with an if statement, it prints can't divide by 0. Isn't this something? But we can make it even simpler. if we add an symbol and the decorator name right before the function to decorate, it still works just the same. This is the pie syntax. We can also apply more than one decorator to a function using the pie syntax. These are two decorators. One prints dollars around a function's output and the other prints hash signs. To a function say hello, we apply both the decorators. The output has both dollars and hashes. Notice that hello is first wrapped by hashes and then this is wrapped by dollars. This is because the pie for decor 2 is closer to say hello than that for decor 1. So while decorators are helpful and add reusable behavior to code, they also have some disadvantages. Decorators hide the original function since they modify it, leaving it impossible to unit test without the decorator's behavior. Now you know decorators and how to use them.